Howdy folks, welcome back to another midweek machining video where I yet again tackle a fuel T or a fuel joint or both. In this case it's just going to be a fuel T. But instead of just making the thing, I figured I'd bring you along for the design process because I do not have a working drawing for a Valkyrie fuel T. I do have one for a fuel joint, which is the ones I made, the straight fuel joints. The ones I made for the bike I'm working on right now, the 97, which I don't know where this video in the midweek machining series will come out relative to video 2 of that Valkyrie, because video 1 is already dropped. So I don't know that yet, so I hope I don't confuse anybody. But that particular bike needed fuel joints, the straight joints, because the O-ring grooves were completely corroded. I have already made those, didn't film any of that. It is pretty straightforward. Here's one of those. And I made a working drawing of this. I'm kind of testing out an online CAD software, so I made a working drawing of it after I made it. That way I have a print, so if I ever need to make them again for somebody, or myself for that matter, if I'm working on another Valkyrie, I don't have to scramble. I can just go look at the drawing, whip out some material, not any bigger than this 3/4 inch hopefully, because that would be a pain, and then we'll crank out a few of these more if we need them. But in this case, I do not have any working drawing on a fuel T, and that's what we're going to do here, and we're going to go ahead and make one as a prototype to make sure that it works, because there are some space limitations between the two carbs that they go on, and I'm going to show you that here in a minute. But the first thing we need to do is establish the dimensions that we know. That's usually the first thing I do, and these two guys over here are going to play some relevance in explaining all this here in a second, because we're not going to be able to make it exactly like this. The ones that you can get from Red Eye Technical, which are excellently made metal ones, CNC Machine 6061 according to his website, which are out of stock. All right folks, I need to clarify that last statement about out of stock. They were out of stock at the time that I filmed and edited this video. That doesn't mean that they'll be out of stock when you want them or need them. So depending on when you watch this video in the future, they very well may be back in stock. So very shortly there's going to be a link in this video to his website. You can go take a look and see if he's got them. So just don't take that as they're always out of stock, because I don't know that, and I don't want to get in trouble. So yeah, if you need them, go there and check it out, because it's likely he's going to have them. Are very similar to this, except the center section has got a square section, and then you have the two ends, and then you have your spigot on the top like this. So I'm going to kind of use his deal as a benchmark, because they are very nice, and I think I can explain why he did his design the way he did. But the first thing we need to do is make some notes as to the stuff that we know needs to be a certain size, diameter, or length. We'll write that down here with a crude drawing, and then we're going to pull a couple of carbs out, and I'll explain why I think it needs to be a certain shape, and why we actually may even need to offset this spigot to one side or the other, kind of like we do on the ZX10s on the Valkyrie carbs. So we'll go ahead and do that now and then move on to that stuff. All right, so we'll make just a crude drawing here based on the original. It really doesn't matter if it's all that accurate, it just needs to be something that I understand, even if nobody else does. If this is not to scale at all, this top section would be a little wider, because it would represent this part right here. Let's go ahead and just measure the O-ring dimension as far as the groove goes. We'll do that. It should be the same as the ones I've already got a drawing on. Yeah, it is, because I remember that was like 315. These are slightly smaller. Yeah, I'm doing this imperial because I don't have any metric measuring tools except a scale. So right now this is measuring out at 312, which is basically 8 mil. I know the ones on the steels measured out at 315, and I ended up doing those at 320. I wanted to add some to it, but what we're going to do is we're just going to go ahead and note it as it actually is. So that's going to be typical between the two sides. I mean, I can check it, but I don't think it's going to be any different. Well, one side's 311, one side's 312, so Close enough. Now, next thing we need to know is the major diameter of this and that. Now, keep in mind, this particular design plastic has these ribs that are molded into it for her pleasure. And what these do is just give it some strength, especially from, you know, the lateral forces that this might experience from a fuel line. You know, to kind of beef that up, the spigot. I didn't include that in my drawing because it's not going to be relevant to what we do. But we do need to know what this major diameter is of the end and right here where there's no reinforcement. Yeah, we'll go 419 thou. I'm going to also make sure that the ends are the same, which they are. They shouldn't be any different. I'm talking about the ends that are outside the grooves, and they are the same. Now I know what the inside hole is already at. That's for the main body. I don't know this yet, but I do know this. And what this is, as far as a hole, clearance hole, that is going to be a letter C drill bit, because I used that to make the fuel joints, and I know that that's the right size for this. So we're just going to put letter C drill bit. I don't know what the dimensional or fractional or decimal dimension is for letter C, but I'll put it here underneath. I'll put it in text here somewhere so you know. But it's a letter C drill bit, I know for that. But I do not know, what I do not know is this one here, because I've never measured, I've never made one. So this tube is fairly interesting because the spigot opening, as far as the major diameter of that internal dimension, is definitely larger than the hole in which that goes through it for passing the fuel, which is kind of interesting. So usually it's all about the same. So let's see, we're going to measure this up at, that's about 311, 312, which is actually about the same diameter as the groove, which is kind of interesting. Yeah, that's really something. I'm kind of, it's close, a lot closer than you would think it would be, but maybe not, I don't know. So 310 would be the hole for the inside the spigot. That's where we're going to go with it at least. And then we need two dimensions on the spigot itself. We need the spigot diameter, which is where the fuel line goes over. Now, could you change that? Yes, but why would you? Because you want, this is gravity feed. If it was a fuel pump bike, it wouldn't need to be this big. It would be much smaller, like the ZX-10s, you know, that has a much smaller orifice size, if you will, the hole, because it's a fuel pump bike. This is gravity feed, so it's going to be bigger. Now in this case, the major diameter on the smaller part, or the shank of it, if you will, not the head of it, shank of it is 0.400. We just need to know how much larger we need to make this part and then kind of taper it down. This is the kind of the head of it, or the barb of it, if you will, not barb, but the larger area in which a hose pops over. You put a hose clamp down below that and it keeps it on. So that's going to be 426, subject to interpretation or modification. So that gets us to that point right there. Now I'm going to go ahead and pull over two of the carbs that go together. The fuel T's go between the rear carbs. So that means they go between 3 and 5 on the right side, and 4 and 6 rather on the left side. Doesn't matter which two I grab, but I just need to grab two of them because it'll be a mirror image on the other side. All right, folks, I got 4 and 6, which I probably should have grabbed the other ones because this is going to look a little backwards, because 4 and 6 go this way on the left side of the bike. So really, if you're looking at it from the point of view of the way these things would be sitting in an assembled rack, it would be like this, with these guys on this side, because this would be the front. 2, 4, 6. And, well, you can't see over here where I'm pointing, 1, 3, 5. But unfortunately, you're not going to be able to see too well because the fuel joint's going to be way back here. So you're just going to have to understand, we're going to be flipping this around here and there to give you a better shot what I'm talking about here, because these guys obviously are going to go together that way with those pins lining them up, and everything is correct because you can see the paddles for the adjusters line up, and you know that they're right. In other words, they're not flipped around. And of course the the carbs are in the right orientation because you have your enrichers pointed the same way and so forth. So what we're going to do here is flip this around because we need to show you the back side of this. I need to show you her backside. All right, so to demonstrate the issue here, again, I'm going to be flipping it around this way to show you. Now typically, or normally, let's say these were the two right side carbs so you can just get that idea. Let's say this was 3 and 5. You would have, of course, the intakes toward the outside because, you know, it's a flat 6, so the intakes are coming in this way. The center would be where your air box is, and below that is where all the fuel lines and stuff line up to, and other hoses and so forth, as you probably already know. So we're going to put this fuel joint in here, just laying it in without any O-rings, and we're going to line up this thing and shove it in the other one. Shove it! And get her so she starts. There we go. Okay, so now she's back together the way she normally would be with a fuel joint in place. Now, I like to do this because I want to see how much left to right thrust there is on this, in case I want to design in a little more length. That's really not that bad. I might add a little bit, and you notice I haven't measured the length yet. So when I measure the length of this thing here in a minute, I may add 30 thou to it to tighten that up a little bit. But the problem we're going to have here is going to be the closeness of this to that, because in a stock situation it's no problem, there's plenty of room. But we're going to have to make this center section a lot bigger, because like we do on other ones, we need some meat to be able to push the spigot into. We can't just put it into the same size, there's no meat there. Let's look at this commercially available one to give you an example of that. You see how the center section is larger, so there's enough material to push in the spigot and press it in. And you can see right now, if you swing this up, this is going to hit the carb body right there. So if this is fat down in here, what I mean by that spot way down in here, like right there, down inside here, when this rotates up like that, it's probably going to hit it if it's a square. And I think we're going to have to leave it a square. I don't think a round or, you know, octagonal or anything like that, or a hex shape piece is going to help us at all. I think that's why the ones from Red Eye Tech are square. They're not a very wide square, but they're square nonetheless. And he does not offset those. They are in the center of the fuel joint, fuel tee rather. I'm thinking we need to offset this a little bit. I think it would be more comfortable. There's no reason, nothing is going to get in the way if we bring this spigot over to about here. So if we were going to bring that spigot over yay amount, this is where we'll switch over to millimeters because it's a little easier in this kind of situation. If we were going to bring this spigot over a little bit, how far would we do it from center to center? If we brought it over 10 mil, that would work pretty good. So if we brought this spigot over so the center of the spigot was 10 mil that way, I think it would be a lot better. And we could make that square section a little bit wider as well, because that will follow the center of this spigot, and ergo it's not going to have any contact problems with that. So I'm thinking that's what I'm going to do, is shift this thing over. I'm going to make it a little longer because I don't like this, and I'm thinking we're going to shift it over 10 mil, and that way it'll be more toward the center of this. And it'll be the same for the other side. So even though this one goes this way, I think the other two carbs, it would be a mirror image if I'm not mistaken. I'm not 100% sure of that, though. I think so, yeah, because this would be an end carb. So I think either way, it doesn't matter, because all you do is take this out and flip it around, and it's going to be a mirror image. It's going to go that way. So instead of it being offset to this way, you may have to flip it around and offset the other way. I'm not sure. But I'm pretty sure this would work for both sides. I am sure it'll work for both sides. And I'm pretty sure as well that it's a better option for us design-wise. So let's go ahead and take this out, and then what we're going to do is we're going to figure out what size that square should be. Just kind of guesstimate that, because we know what size this diameter is 400 thou, and we know what this side would normally be if it was one piece. you know, cast as one piece or otherwise machined as one piece somehow. But we need to make this center section bigger, and we'll figure that out, and then figure out if this stock over here is actually large enough to do that. I don't have any square stock, so we're going to have to mill that square first, or mostly square. I hope I'm not confusing everybody on this. I'm trying to be as clear as mud, but sometimes it doesn't work that way. Let's get an overall length on this guy. That would be 2.521, 2.522. Let's go let's just do 2.520. We're going to adjust this anyway. So if we were going to add 30 thou to it, we would do 2.550. That'll be 15 on the side, 30 thou total, and that will tighten it up a little bit. And there's nothing inside these holes that would give you a problem with that. And it would also bring, in most situations, it would bring to bear a fresher spot for the bore inside here for an O-ring to seat, because these things tend to get corroded where the ones we're sitting in for 1,000 years. So that's another reason to do that. Now on the fuel joints here, I did not do that. I did not make them longer. Well, maybe I made them slightly longer. Let's see if those are the same. And I think I made this to the original joint length. That's 2.480, let's say. So these were 2.520 nominal without lengthening them at all. So what are we talking about? 10, 20, 30, it's 40 thou difference. So there is a little difference between two of them. And again, I don't think I made these any longer, or maybe a little bit longer, but not much. But, you know, that's the way it is. So I think we're going to go ahead and make the fuel T, though, a little bit longer because we can in this situation. These fuel T's tend to, well, you know, I shouldn't say that. I was going to say the fuel T's tend to attract the most corrosion in these carbs, but that isn't true on these because they're plastic. Most definitely, the fuel joints in this bike, because they're aluminum, attract the most corrosion at that spot, and anywhere where this penetrates into this bore. And so that's aluminum and moisture and corrosion, a transfer of corrosion into the adjacent place where this is stuck into, in this case, this bore. So not necessarily the case, so I shouldn't really say that, but it would still be nice, I think, to have it a little bit longer. It would certainly make me feel better. So anyway, like I said, we got to figure out how big we want to make that square and whether or not this material is going to work if we square it off. Alrighty, according to the interwebs, you take the dimension across the flats of the square that you desire to have, which in our case is 0.550 from here to here, and also from here to here because it's not a rectangle, it's a square. And you multiply that times 1.414, and that comes up with the size of the stock that you need in round bar to accommodate that, so there wouldn't be like any round edges or something. In other words, you can get a true square out of it. And that number would be 0.777 imperial, so just over 3/4 of an inch. Just over. Just so happens that I got 3/4 of an inch bar stock here. So what's going to end up happening here is, it doesn't matter to me if there's a little round edge on it. In fact, I would desire that it would look better. I don't need to have these squares absolutely square in this case. I think the way we're going to do this is, I don't want to take the forejaw out. In other words, mill the flats on this and turn it into a square bar and then have to cut everything else in the forejaw. That's a pain in the butt. What I'm going to do first is I'm going to machine down what I'm going to consider the long side, because we're punching this over 10 mil or about 3/8 of an inch to one side. We'll do that first, and we don't have to even bring it to final dimension. We can leave it, you know, 10 or 15 thou big. So when we rechuck it up on the other side to cut that one, that'll be after we do the flats, these flats in the mill in a collet. So we'll put the end that we turn down a little bit big in a collet, put this in the mill, take off the appropriate amount to bring it down to square. As long as the rest of it's square, who cares? And then we have a round part we can chuck back up the other way. We'll cut that part, and we can always bring these ends down to dimension later on as far as their final dimension. Then we'll shoot the grooves in them, then we can do the spigot part. But what I need to know here is, if I'm going to bump this over, how far over, how long will I be making that longer section, And is that going to be good enough to do what I just described in a collet? I think it will be. You know, I'm thinking 3/8 is going to be too much, because I just checked this off camera, and that would be 1 9/16, and that's just too far. Yeah, 5/8 is 625, that'd be 562. I'm thinking 7/16, so it'll be 1.4, let's go 1.437. Yeah, if we go 1.437, I think that's probably going to be better off, because there's your 1.250 right there, your halfway point. And if we go to 437, I think that's going to push it over just fine, and you're going to have plenty of material there over on this side, because if not, this end over here becomes really, really short. So I don't think that was, again, this is stuff that goes on when you're designing by the seat of your pants here. I mean, if I don't have 3D software that I can plan this stuff out, I have to do it this way, and then write it out, and then just do it in something where I can put it into a drawing format, really all it is. If I had a drafting table and some pencils and some time, I could do it the same way. That's all I'm using that software for, is to document this in a more of a blueprint format, not designing it. So I'm doing all this off the cuff like I normally do. 1.437 to the center. We're going to offset it. Now that question is relevant to, again, do we have enough material on that long side to put in a collet and then mill our square stock over it. So essentially it's going to be like this, where we're going to turn this down, and then we'll have a larger round bar coming out of the appropriate total length. And so we need to put this part in a collet and then mill this. I don't think that'll be a problem at all. We don't really have to take that much off. So that's what we're going to do, but we're not going to drill anything first, because we want to keep this as solid as possible, so no drill bit through it until later. And we'll make this a little bit big so it doesn't get screwed up in the collet, or when we rechuck it, turn around and cut this part down to where it's supposed to be and get rid of this, and then we can finish it up and put the grooves in it and then figure out what we're going to do for the spigot. So I think that's probably the best course of action or order of operations for this. One thing I didn't go over with you yet is what the width of this is going to be. Now, I figure we just might as well make it that 550 thou, that the width of it is that way. In other words, when you're looking down the end of it, it's going to be 550 thou, and since it's a square, why not just make it the same? So this isn't a rectangular, it's actually a square. So since that's 550 thou, we got to remember that this is offset to the center line, 1.437 on this side, and it's going to be considerably shorter on the other side, which I got to make sure I calculate out properly, but that's later on. The whole point here is we got to turn into where that edge is going to be, where we're going to do the square piece. Once we face this end, we got to turn in a certain amount so we still have this left over to go into the mill and do that square operation to square up the stock. So it's pretty easy to figure that out. We just take half of the 550, which is 0.275, and subtract it from the 1.437, and that's 1.162. So we just touch off and go 1.162. That's going to bring us to this edge. We maintain that edge. Again, we'll turn this down 10-15 thousandths big, and then once we get to that point, we can just cut it off at that point to the appropriate length. Then we'll go ahead and put it in the mill and do that squaring operation, like I said. The other side we'll just figure out as we go, because I just haven't sat down and take a look at the math on this yet, because we are adding a little bit of length to it. So we got to figure that part out. But since we're going off an edge, we're not calculating the entire overall length yet, so we're going off one edge. This is going to be accurate. Just going to face it off right now. I can push this up in the chuck, so I don't have to worry about using a center. This aluminum is very flexible. I'm only going 1.162. Let's just let's put the DRO on, why don't we? If I come in here, bump off 0 to Z, and go 1.162, where are we at? So we're good there if we tighten that up. And we have, that way, not gonna have any chattering or anything. This crap will chatter. It's not very big diameter, and you know, it's flexible. So 1.162. There we go, 1.162. So we'll go ahead and make a witness mark. Touch off. Whoops, too much. Touch off. Now we'll zero the X. Sorry about that, I didn't have you angled right. I'm sorry about that. I hope those clips are usable. We're just going to turn this down to close to that that 0.419, which is that major diameter. I already got the DRO set for what my depth's going to be. Depth of cut, that is. I can do better than that. Yeah, 429, and we want 419, so I'm 10th out proud. Good. All right, so that takes care of this one. Thanks for watching. Never mind. Let's move on to the next thing. I'm going to try something different. I'm going to mill this vertically. Well, I could still take this out and flip it around, but there's a problem with that, and I'll show you what that is. With a curved vise like this, with that center section that isn't accurate, in other words, part of the casting, the machine sides are the ways underneath the moving jaw, and so we're going to get a reference to those with this parallel underneath there, and the only way to really get that good is to beat it down before you put your collet and your work in. These ER32 collets. This vise is so good, it's too tight. It will not allow it to move, but now it has. I tightened it up too much. Now we'll tighten it. Yeah, because otherwise this part will be off to one side when we mill it this way. I could set up the stop so we just get the same location and just keep going on the x-axis, or the y-axis rather. But again, we just have to keep resetting it because this thing would never get back down onto that. On the side, you can just beat it on its side and it'll go right in, but I'm just going to do it this way and see what happens. We'll put the stock in. This is a 7/16 collet because I don't have any metric. I'm getting all these hurricane alerts on my watch here, which is what you hear going off. We can just use the DRO and move it in the appropriate amount and just do our axes the way we normally would. So that works out well, you know, kind of saves setup time a little bit. Just move the XY axis and Bob's your uncle, you're there. So I'll get this set up for the first cut and we'll go ahead and do that and probably just do it pretty quick. And what we need is 550 is the ending number, 750 is where we're at. So we take 100 the side off and we get that 200. That'll be fine. I mean, it doesn't have to be perfect here. We're not fitting it into anything. It just needs to be bigger. Now we'll just climb mill it without touching anything. I'm going to do one more axis on camera and then I'll do the rest off. We'll do this front one so you can see it. We'll touch off on that. Now we're going to be using the x-axis to cut it instead of the y-axis, but we need to adjust it on the y-axis. Why? I don't make up the rules. I don't know. And again, we'll climb mill very slowly without touching anything, kind of spring pass. Now if I had just gotten, or even just half-inch square bar, I could probably manage 500 instead of 550 on that square. We would eliminate this altogether, but I don't have time to order any and I don't feel like doing it, but I will eventually order some. If this works out. Remember, this is a prototype, so we're kind of experimenting. Okay, let's see how we did. I mean, we didn't make any mess or anything. You can see you just have a little bit of an edge left on that, you know? Come on, focus. A little bit of an edge. Not really a super sharp corner. I mean, this thing is not perfectly square, but it's good enough. But you got a little bit of an edge, which is how we calculated it out to be, which is really neat. 550, maybe 549 and a half. 548 and a half, 547, close enough. So it's roughly 550, which is where we want. More than roughly, it's pretty close, within a few thou. So that worked out just fine. So there's part of it done. We can go back to the lathe now and work on the rest of it. I think what I'm going to do is drill this hole through first, because I want to do it with the most meat on it. I don't want to cut this end down. You know what, I'm probably not going to make a hill of beans worth of difference. No, we'll go ahead and turn it, and then we'll drill it through. I don't think that's going to make a hill of beans worth of difference, because it's going to reference off this long end anyway. It's going to be what it is. And I made it big, so we can crank up on it in the jaws here pretty good, and then just finish turning it down. We're going to need to set the overall length first, because we're going to have to work off this side in order to get that. I don't know how else we would do that. I guess we could pick. I know. You're gonna love this. You're gonna absolutely love this. Watch this. Just thought of it. Let's take this. Let me turn the light on. You're gonna love this. Let's take this jaws right here. This jaw, these jaws. They're a little bit tapered in, so we can't really get up on that flat there. But this is what we could do. We could take a scale. We could put this scale right here, flat up against like two of these jaws, spread it out, and then shove this in so it's just hitting it. So that shoulder is hitting the scale, just like that. So essentially we know where that is now. Then we tighten it up and we got a nice firm feel on that. You see how that is? So we're using it like a feeler gauge, which is really cool. Now, we measure this, we touch the tool off to that, to the appropriate amount for 550. Actually, we'd have to add that, I should say. We'd have to add this amount because we're that far away from the chuck face, the jaws face, because of this being in there. So we go 550 plus whatever that is. That brings us to 550. We set a 0 on the Z and then we just cut up to that. Then we can finish the final length, because this section right here is going to be what it is, you know, from here to here. But I do want it to be square in the middle. So that's how you do that. All right, Mr. Scale is 40 thou thick. We're going to go over here and just bump this. That's good. I mean, if you really wanted to be accurate, you can put a feeler gauge there. Let's 0 the Z and add 40. So we're going to go plus 40. Anything toward the chuck is minus. So we're going away from the chuck, so it's plus 40. Now we're at 0 again. So really all we got to do is come out 550, which is what we want this to be. Well, that's 616. We don't want that. We want 549.50. We 0 the Z. Now when we come in, we come up to that 0, and we know that that's going to be the right thickness in the middle. And then we turn this down to the same, what I go, about 429. So there you go. Now we got to back this off. I don't want to smack this thing because we're cutting down a square, turning down a square. Okay, so that's it. Let's do it. I'm going to switch back to a high RPM. I think we'll just do 800 again. And I got to reset my feed because I turned that down for parting. Oh, come on. Here we go. Touch off. So we generally know where we are. X. I need to go way faster than that. Yeah, I'm where I'm at. I'm about 10,000 over. Glad I didn't cut any more. I looked at that and went, whoa, wait a minute. So we're about the same place now. Let's go ahead and take it out so we can look at it. It gives you an idea what we're going for here. So there's our offset side. You can see it, and you've got the big section in the middle, which is 550 thou. This should also be, oh, I didn't finish that up, did I? I can put it back in and just touch off on that. Yeah, this is a little bit big. I just forgot to do that. I always come up short and then clean up that face. So I'll do that off camera, but we're basically going to be at 550 all the way around as far as the square goes. All right, so I'll do that, and then we'll come back and figure out what we're going to do next. All right, we're going to drill a hole straight through it. Remember before I said it was a letter C drill bit because I assumed it was the same as the one that I based this off of, which is the original aluminum one, which a letter C drill bit fit perfectly inside of it. Letter C is 242 thou. It will not fit in here. It's too large. This is a letter A drill bit, which is like 234 or something like that. So this is a letter A drill bit. Why this is smaller than that, I don't know. Just the way it is. So I'm going to make it the way they made this one because it worked before in the plastic configuration, and I'd rather have a smaller hole to deal with in here than a larger one at this point. So there are benefits to running a larger drill bit than a smaller one, of course, so the drill won't tend to wander or deflect so much because it's bigger. But you know, we're only talking 20 thou difference than the letter C drill bit or so, approximately. So that should be fine. So I'll go ahead and center drill that and we'll punch that out. Centered on both ends, which is nice. Sometimes I've had them walk and doing these joints and I had to scrap the joint and make new ones. And I can't understand why exactly, except I think I left this too small. Tried to drill through with too much stick out, and the work kind of flexed. So that's why I'm trying to drill them now with a little bit more meat on them. All right, folks, I went ahead and took this down to final overall length. It needed 30 thou taken off it. That was just a random amount I left long when I parted it. I decided to take it off. Well, I don't need that. I decided to take it off the long side over here instead of the short side because this was already, it seemed too much biased this way I should say, than this way. So again, it's just a little design change on the fly. So I took the entire 30 off this side. I'll put all the dimensions in at the end in a drawing, or I'll go over them with you once this thing is done in case you want to make something like this. But, or at least let you know what I did in case you want to change them, I don't know. So again, it is the correct overall length. These are still big. This is the correct length and width. And so now we're going to make the spigot. I just got a piece of scrap aluminum. I'm just going to bang that out real quick. I'll probably do some sort of a time warp or something with you, and we'll bang that out. I went ahead and centered on this center section as I typically do. with the edge finder. I ended up jamming the edge finder up right here against it and kind of marred that, but I still have to turn this anyway, and this is not anywhere near an O-ring surface, but this is a prototype anyway, so we're just making sure that it's going to work. So I'm going to recenter on this with a center drill, and I don't have a reamer a good size for this. That piece that goes in is like 400 thou OD, so I just don't have a good reamer that size. I'd have to cut it down. I'd have to cut the bottom of it that gets pressed in pretty small, and there wouldn't be much wall clearance between the drilled hole in there, the hole I should say in the spigot itself, and the outer wall. So I'm going to use a 10 mil end mill to plunge in there, and then we'll just make the spigot to fit that, put like a 3 thou crush on it, 2.5, 3 thou crush, depending on what this turns out to be, because this is never going to cut exactly right. I'm just going to do it in a drill truck. Well, maybe I'll put it in a collet, I don't know. But before I do that, I'm going to center drill it, and I'm going to run an 8 mil spotting drill through it first. And I can tell just when it breaks through into that hole and goes into the bottom of that radius, you know, for the cross hole. And that'll be our total depth. But let me go ahead and set back on 0 here, because I had to move it off to get the chuck in. You got to work with what you got. I need to order some reamers of different sizes, especially metric, but they ain't cheap, you know, and this channel doesn't generate that kind of revenue yet, so we're just going to have to use what we got. Yeah, baby, it fits. I've heard that before somewhere. Yeah, there it goes. See, now it just took out all of that and it's down to the radius. That's what you were feeling. The flute's grabbing the side of it, or hearing rather. The flute's grabbing the side of it. Now it's at the bottom of that radius. That's why you have to make this so thick, because if you did that on this, obviously you'd break through. There wouldn't be enough material there. Just plunge that down to about where the other one, I'll be able to feel it hopefully. I'm going to use a fine feed for most of it, then I'll finish it off with the quill, just a straight quill, so I can get some feedback from it. Well, guess what? I'm at my stinking max depth. I didn't realize that. I just extended the tool out a little bit in the collet. That'll be good enough. I only need a little bit more depth, but... like about right there. Well, I'll show you later. I can't take it out right now. I got to maintain this 0, because we're going to use this spot to push it in. I'll just deburr it in place. Blow it out with some compressed air and then brake clean. And like we did the last one for the, I don't know, forgot the last one I showed you. The way we did that one, we just did it in place. So I gotta make sure I stay on 0 here. And then we'll just do it that way. And push it in the appropriate amount. All right, so there's your hole. It's down, you know, pretty far. We'll have to run another drill through or a needle dick file and deburr all that, but really the best I can do with this setup right here. Focus, and then that should be good. Yeah, it'll be okay. I mean, I don't want any particles in there, but we'll just have to, like I said, deburr it by hand. I really wish I could have gone a little deeper and cleaned that out, but it is what it is. Let's go ahead and see how true to 10 mil that cut, with that kind of reach out in this, or that kind of stick out of this quill in this particular mill drill machine. I'd be curious to see what it really is. The calipers say it's about 390, but these very, very small spring gauges are very fiddly to get a good feel with. I could get a 10 mil drill bit and see if the shank goes in. How it goes in. That's showing 95, 75, 85, 95. And that's a pretty good feel. Maybe a little bit tight. Yeah, it's pretty good feel both ways. Like I said, it's very fiddly. It looks like cut about 5 thou over, I'd say. Looks like 95, 395, 395 thou. Well, anyway, it doesn't really matter what it is. We just have to make the part a little bit bigger, and I can sneak up on it in the lathe. And we are, again, at something here. Let's see, we are at about 409. We want to go to 95, so we need about 15 thou then. It's almost 10. All right, good. Should be about 10 right there. All right, I screwed up. I got to make another one, so I'll come back when it's up to the same point. All right, so I kind of screwed up on two things. First of all, this is all back to where the other one was, except this one's got a hole in it. I didn't want to do the hole in the lathe. I wanted to do the hole in the mill, because I knew this would be fairly thin-walled, and I was afraid pushing it in, being thin-walled, it might crush it. So I'm going to kind of gamble on that. But the other problem I had was this overall dimension right here was at 400 thou, which is the hose dimension, and I forgot to leave the heavier part at the top for that little kind of, I don't know what else to call it besides a little barb or something, you know, a little bigger area. And when you put a clamp that way, the hose can't slide off because it's larger. It's only 25 thou more, so this is at 425 now. I got to bring this down to 400, up to about here. So I got to put this back in and very carefully turn it down where I leave a little bit at the top and a little bit here. So this center section will be at 400, because I want to leave a little bit on the edge here as a little step to push up to. Even though it would be anyway, I think, but it wouldn't be much of one, because that's at 397. Now, this is another mistake as well in the operations. I should have left this piece longer. I don't know what I was thinking. Now I'm chucking it in a precarious manner, and I have to use the tool that I don't want to use to try to just plunge in a little bit and then bring it down that way. I only have to take a little bit off, but it still bothers me. I didn't think that far ahead, but it is a prototype, so. So we know we're at 425, yeah, 425 or 426, so we'll just come in 12 thousandths and sweep back. We'll do it in 2 passes, do 6 at a time. I mean, I know it's not turning straight, but all cattywampus, but it's just kind of relief anyway. It's just kind of relief for the hose to sit down in there. Yeah, a little bit more to go. Yeah, as high as I can get up in there. Can't get up no more. That should be fine. Good enough, close enough. I don't want to chuck on this part here. See, if I chuck there, that's the part that's getting pressed into the other side of the T, and I don't want to mar that up. So I'm chucking at the other end where the hose goes on. I could really care less about that. We'll have to, before we do that, there's a higher ridge there. I want to take you higher and put it right there, and we'll kind of buff this end out. Like I said, I kind of screwed this up. I should have left this long. This was dumb. This is different than what I normally do with the sizes, and so it's kind of throwing me off because I have a rhythm going when I make the other ones. But you know, it'll work. You know, it'll work. So I'll just clean this up really good off camera, and then we're gonna go and proceed and push it in. All right, folks, ready to press, and I'm well aware that there are no grooves in this yet, not even down to size. We're going to do them afterwards because this is longer than the ones I normally do, and they're completely accessible as far as those ends. Just chucking them up in the lathe, this thing's spinning around as far as this little spigot is not going to cause a problem. What I'm trying to do here is put some freaking Loctite. I want this one, even though it's a prototype, I want this one to be exactly as if it would be if I was making it for a customer, because I want to test it. I want to test it and make sure that it's going to seal up and there's not going to be any leaks. You know, we'll pressure test it. Now I am on 0-0 this time, right? Yes, I am. I bumped that a little bit. See if we can shove it in. Shove it, she said. Oh yeah, that's good and tight. Oh yeah. Oh yeah, that was really hard. So that's good. You should have a really, really good press on that. And we can take her out of the vise now. I love this Kurt vise. This thing is just absolutely the bomb. Compared to that Vevor, when you put parallels in it, they don't fall over before you get everything tightened up. I mean, it's just beautiful. Yeah, pretty cool. I like it. All right, so now I'm going to go over and bang out the grooves in it, and then we'll finish it out. We'll test it. I'm not going to put any O-rings on it, but I want to test it for the length and stuff. All right, finish size is 419. We're at like 430 something. I'll put you in time warp. We'll finish that up. And I'm probably going to put you in time warp for the groove too, because you've seen that a bunch on other videos. We'll get this one kind of finished out here. So right now we're at 434. So we're going to bring her down to what I say, 419. Here we are back where we started. And here's the finished product. Mostly finished. I still need to run a drill down the end to clean that out. But again, it's a prototype. But I wanted to make it sealed off like it would be if I was making it for somebody. And we're going to go ahead and install it now. And I'll show you how that offset compares to the stock one. And also the end play. So, got to do it this way. Yes, the paddles are there and the adjuster is right there. So that makes sense. This is actually a lot easier when there's O-rings in them because they stay in one side. There it goes. All right, so the first thing I want to see here is this end-to-end play. Remember, this one was quite a bit. And this one, I think, is about perfect. That might be 30 thou. It's okay, but I think this is better. And so you can see this offset, how that works. The longer side is over here, shorter side's over here. So yeah, that is correct the way this is set up and the way I designed it. Because now, you remember this one would hit this edge up inside there because it's way far over to the side. So when this thing's in, it's like way over here. This one, more toward the middle, and it gives you a lot more clearance. So I'm not really sure why this is like that. I guess because they didn't need to do it, but I like my design better, and I like the fact that there's plenty of play between, I mean very little play rather, between the ends of it, which kind of brings the O-rings to bear in a fresher area of those little bores in here. So I do like this a lot. I'm just going to have to refine the design and refine my print, and then refine the order of operations. I really screwed up the order of operations on this spigot. That I made that about 10 times harder than it needed to be. But again, I'm doing a totally different one, so I got to refine those order of operations based on each one. They're similar, but yet they're different. So yeah, I think this one came out good. So we'll put this one up as potentially available, or I should say available, if people wanted me to make them for them. But they're not going to be cheap. Like the ones from Red Eye are like 12 bucks a piece. These ain't going to be no 12 bucks. I can't do that. That's that cheap. So if Red Eye Rich restocks these in this configuration, that's pretty much the same as this, you order them from him. But someday he's not going to be able to get them anymore, and nobody else is making them, but I can. So that, I guess that's the root or the net sum of this video is I can pretty much make any custom fuel joint you need, but now I'm going to have the drawings on hand so I can make them for a Valkyrie. So that's it. If you like this video, you know what you need to do. Like, share, subscribe, and ring the bell. Do all those things you normally or hopefully would do. It helps me out immensely. Get notified when I put more junk like this up. Stay tuned for future videos. As always, thanks for watching. Don't just repair, restore, or create, for that matter. I don't know. So with that, we'll catch you on the next video.